Job sequencing using branch and bound method with deadlines, penalties, and execution time. So in FIFO branch and bound method for job sequencing with deadlines, jobs are scheduled level by level using queue-based approach, ensuring a total execution time summation TI should be less than equal to DI, which is deadlines. That means execution time does not exceed the deadline. There is another component which is called penalty. Penalty for the unscheduled jobs is minimized, is P total equal to EI. The cost function evaluates each node as cost equal to P missed job and lower bound which is plus lower bound which is positive solutions. So now let us, so basically the deadline should be, the execution time should be less than the deadlines. This is the main thing, and there will be another component which is the penalty. Each job will be associated with penalties. So let's say we have four jobs: job one, job two, job three, and job four. Uh, so job one penalties are given. Job two penalty is 9. Job three penalty is 5. Job four penalty is 2. And also associated deadlines are there. Job one deadline is 1. Job two deadline is 3. Job three's deadline is 2. And job four deadline is 1. Similarly, the execution times of each jobs are also given, which is 1, 2, 1, 1. Now using state space tree and branch and bound method, especially FIFO branch and bound, will solve this problem. So FIFO branch and bound state space tree will be applying. So first what we'll do, and initially the upper bound will be infinity, upper bound will be infinity, and once we get the lower value than infinity, then we'll update it. So first we chose this job one, J1. Okay, first two things. One is the cost, another is the upper bound. Upper bound means penalties. So first, initially when we pick, for cost, let's say if we pick job ith, if I pick the ith job, then until I minus 1, all penalties will be summed up, and that will be the cost. Okay, let's say I'm picking job J3, then job J1 plus job J2's penalty will be the cost. If I'm picking job J4, then J1 plus J2 plus J3's cost will be the cost for the J4. But when you will calculate the penalty, that is the upper bound, like if I'm picking job J4, then all will be added J1 plus J2 plus J3. If I'm picking job J3, then J1 plus J2 plus J4. Okay, these all remaining jobs total summation will be the penalty. So every time you have to calculate the cost and you have to calculate the upper bound. If upper bound or cost anything be more than this existing lower upper bound, then we will kill that job. We'll see this. So first, let us say we are choosing job J1. So job J1 initial cost, because this is my job, I haven't started with anything, so cost will be 0. Upper bound, because I'm choosing job J1, so remaining job which is J2 plus J3 plus J4, which is 9 plus 5 plus 2 equal to 16. 16 is the upper bound. If I pick J2, then J2 means cost will be how much? Cost will be the J1 cost, which is 4. That means 0, initial cost of J1 is 0. Once I'm picking J2, 0 plus 4, not pick J2 because already I'm in J2. So the 0 plus 4, 4. The upper bound will be J1 plus J3 plus J4 because I have picked J2. So it is nothing but 4, 5 plus 2, nothing but 11. Now if I pick job J3, in this case cost will be up to job J2. That means J1 plus J2, that is 4 plus 9, which is equal to 13. And upper bound also 4 plus 9 plus J4, which is 215. Now here we have to see every time whenever we get the upper bound, then you have to update the global upper bound. So initially I've started with infinity. Once I get, while choosing job J1, upper bound is 16, I will update this infinity by 16. Next time when I pick J2, my upper bound is 11. So I'll update because 11 is less than 16. I have a better upper bound because it's a minimization problem. So I'll pick 11 here. And then third time when I pick J3, my cost goes to 4 plus 9 because J3 is this one. So 4 plus 9, J1 plus J2's cost, J1 plus J2's penalty, which is nothing but 13. And also upper bound is 4 plus 9 plus 2, which is nothing but 15. So 13, if the cost goes beyond this upper bound, then also it is a problem. We have to kill the job. So 13 is greater than 11. Right now we have 11, 13 is greater than 11. We have to kill this job. So if the cost, if the cost is going beyond this upper bound, then also then also you have to kill the job because it is much more. I mean the already existing upper bound is lesser than the cost. How can we take the more cost for the related job? That has to be excluded. That means that has to be deleted. So 13 is coming the cost. Either way, it is whichever is costly. Like 13 is costlier than this one, 11. So we have to kill this job J3. So no more further branching. This is the dead node now. So 2 and 3 could be the live node, but job node number 4 is of because of job J3 will be the dead node and we have to kill this node. Similarly, job J5, I mean job J4, which is node number 5, taking this 4 plus 9 plus 5, which is nothing but 18. Again, this cost has go beyond 11. So there is no need of checking even the upper bound. Whichever way is greater than the existing upper bound, we have to kill that job. So we are killing this job J4 also. Now let us come to the next level of node expansion. So if I expand this node further because it's a free for branch and bound because node 2 has come early in the state space, we have to expand this. So job J1 I have picked. Let me pick job J2. Once you pick job J2, then cost again it will be because again it is a starting point from the second level. So cost will be 0. Upper bound because I have already picked J1, J1, J2. The left out job is nothing but J4 plus J3, which is 5 plus 2, 7. Now 7 is the upper bound. Now I have global upper bound is 11. So I'll update 11 by 7. Okay, so I get better upper bound here from this once I pick job J1 and then job J2. 7 is the upper bound. So I'll update this with 7. Now if I pick job J3, then again if I pick job J3 means the cost will be how much? 0 plus 1. So this is J1 then J3. That means J1 and J3 excluding J1 and J3. J2 is there which is 9. The cost is 0 plus 9, 9. And 9 is already greater than 7. 9 is greater than 7. We have to kill this job. Similarly for once I pick J2, if I after that and then afterwards if I pick job J4, then also this cost is coming 14 and upper bound is also 14. So 14 is greater than 7. So we have to kill this J4 job. So no more further extension for node 8, no more further extension for no more branching for 7, and then you will come at node 3. Now if you pick job J2, after that J2 if you pick job J3, you pick job J3, then J3, then J1, J2, J3. J2, J3 is 9 plus 4 has to be excluded. So 4 is the cost. 4 is the cost. 0 plus 4, 4 is the cost. And upper bound will be 4 plus 2 because J2, J3 I'm picking. So J1 plus J4 will be the upper bound, which is nothing but 6. Now 4 is being the cost. So if 4 is the cost, then I can update this uh, I can update this and also upper bound is 6. I can update this 7 by 6. I can update this by 6. So this is fine. Again, if I pick after J2, if I pick J4, then cost is coming 9 and upper bound is coming 9. So 9 is greater than 6. So this job has to be killed. So further, if you pick another node which is let's say job J1 then J2, if you pick J3, then you will see that in this case the J3's deadline is 2 and execution time is 1. Already first second slot is already over, so I cannot pick J3. That means no more further extension or the branching is possible, so deadline is over here. And similarly in this node possible extension node which is 9, in this ninth node also if you pick J2, then J3, and then J4. Then J4 also, the deadline for J4 is 1, execution time is also 1. So there is no slot remain because it is 1, 2, 1, 2, and then further no more execution is possible for J4. So there also deadline over. So no more further extension, dead node it become node number 12. Similarly, node number 10 also, you pick after J2, J4, then also upper bound is 9, and then 9 is greater than 6. So you have to kill this node. So this is how, so there is no more further branching is possible. So finally, what is the result? Result is J2 and then J3. So therefore, minimum cost that will give us is nothing but 4, and that has come from J2 and J3, J2 and J3. So J2 and J3 corresponding penalties, saved penalties, penalty saving is nothing but 9 plus 5. J2 and J3 is the answer. And what is the penalty paid? That is J1 and J4. Because we pick J2, J3, so remaining two jobs are J2, J1, J4, which is nothing but 6. So this is the final outcome of this branch and bound method using, job selection or job sequencing problem solving using branch and bound method with deadlines and penalties. Hope you like this video.